Welcome to our user guide video on how to operate the software that is using the Raspberry Pi 3 Model B+, the STS Viz Ocean Optics Spectrometer, a USB cable that's capable of transmitting data to and from the system, the micro SD card adapter, micro SD card, and a micro USB power supply. Now, starting off, this is everything that you are needed in order to get started with the installation of our software. The Raspberry Pi 3 B Plus comes equipped with a network adapter for Ethernet connectivity, 4 USB ports, and an already integrated Wi-Fi adapter, which is what we use in our project in order to connect through the internet in order to transmit data to our database on Azure. Now, noted on the Raspberry Pi is the fact that it can be connected through an HDMI to any monitor, and at the bottom, where displayed now, is where the micro USB card is to be inputted. First off, we're going to take the micro USB and we're going to insert it into the micro SD adapter in order for us to flash the Raspbian Pi operating system, which is a Linux Debian-based distribution. Now, once we have inputted the micro SD card adapter into our laptops, we're going to open the Raspberry Pi imaging software. This software allows us to place multitudes of different operating systems onto our micro SD card so that our Raspberry Pi can operate. We're going to be going into the operating system. We're going to choose Raspberry Pi OS and other, and then we're going to be going to the Raspberry Pi OS full. The reason that we're choosing the Raspberry Pi OS full is because the Raspberry Pi OS full comes with all necessary libraries and dependencies in order for the software to run smoothly without any further manual installation of software. After choosing the Raspberry Pi full, we're going to select the SD card that is mounted onto our laptops, and then we're going to simply write. This process should possibly take about 4 to 5 minutes, but really no longer than that, to give you a fresh, clean install of the Raspbian operating system. After the Raspbian operating system is loaded onto the micro SD card, you can then safely eject it from your laptop, remove it from the micro SD card adapter, and input it into the Raspberry Pi as indicated in the video currently. Once the micro SD card is inputted where it should be, the STS Viz spectrometer is connected through a micro USB in the back. It is heavily noted that the micro USB that is to be used on the STS Viz spectrometer needs to be a USB that is capable of transmitting data. If you use a USB that is only capable of charging an appliance, it will not work since it will not be able to transmit the necessary data for the software to connect to the spectrometer. So after ensuring that your micro USB is capable of transmitting data as well, we're going to connect the micro USB to the STS Viz spectrometer. And the USB to one of the USB ports of the Raspberry Pi. It doesn't matter which USB is connected, the software is automatically going to be able to detect which port the spectrometer is connected to. The spectrometer comes capped so that the front of the spectrometer isn't collecting data as it is on. The front aperture of the spectrometer is closed so that it remains in a dark environment in order for the processing of raw data and information be done optimally, just like a video camera or camera works when it is processing information based upon light. So after all the necessary adjustments have been made to the spectrometer and the connections have been made, we are now connecting the micro USB power supply to the Raspberry Pi, and this is where the boot up process will occur. This is the home page of our operating system, the Raspbian OS. Simply by opening up a terminal, Control Alt and T is the hotkey to open up a terminal. We're going to navigate to the project home folder, which should be located in the commands that are being displayed on the screen right now. And by typing python3 controller.py, we are currently now establishing a connection with the UI of our software. The software makes a connection established with the Azure database. If this connection is unable to happen, the user interface will not open, and an error will appear that'll tell you which dependencies are missing that are required for download. Once the connection has been established, we're going to be showcasing the creation of a user profile. This user profile that we're placing in currently is one that is supposed to launch an error on the screen, since this is a user profile that has not been created yet. Once we click login, we'll see that an error appears that this email is not yet registered. We're going to go through the sign up process right now, input all the necessary information. We are inputting the password, confirming the password, and once we click sign up, we have now inputted the authenticated user. We're going to click login and view that the sign up has actually worked, and we're moving on to the next page of our user interface. This is the portion where we're going to include a lot of patient bio information that researchers need in order for them to perform manipulations to data according to the patient that they have gathered the information from. All said information was information provided by our project owner that told us that these are the necessary information that researchers need, which is all saved to our database on Azure. Noted over here on the graph, what is going to occur is that the y-axis is currently a little bit off-centered. We have included a reset y-axis scale, which will recenter the graph in order for it to be centralized more. The integration time is going to be set, all of which can be modified by any of the researchers. These are the number of spectra that the spectrometer is going to return, and this is the amount of spectra that is to be averaged. We're going to select the location of the body that the information is being gathered from, and once we click start, it'll then begin to collect information from said part of the patient's body, and it'll save it onto a .csv file as well. So now we clip stop to record and save. Save automatically logs the patient ID, which is noted above. The patient ID is 218, and the location of the body is the leg. Viewing on the left side over in the terminal, you can see that the .csv file that has been saved is 218_leg. This means that patient ID 218 can be used again, and it can be used on a different part of the body, storing a unique set of data profile on Azure as well. Once quit has been clicked, the data file is going to then be automatically transmitted to our Azure database. Opening 218_leg, we'll see all the data that has been transmitted from the spectrometer into the .csv file. These are all the y-axis information that has been collected from the spectrometer and has been automatically averaged according to the researcher's inputted modifications.
This is the view from the Azure server. From the storage account more specifically, we can see the file uploaded here, the same name, 218 underscore leg.csv. Now we're going to proceed to download the file and check that the data is indeed the same as uploaded before. Let's open up the file now and confirm. As we can see here, the header of the file is 218 underscore L, which stands by leg, and the data is the same as before. This data, it's going to be on the cloud in Azure in the storage account, ready for researchers to use for future calibrations of the wearable devices and manipulation through their algorithm.